Okay, so 10(3) is simplifying radicals, primarily square roots, but we can even do this with other kinds of roots. So in order for numbers to quote unquote escape the square root, remember, in order to take the square root of a number, you need to have a perfect square, which means you need to have a number, the same prime number represented twice, or even a different number. So if we're trying to break down something large, like the square root of 540, sometimes it helps us to take the number and break it down into all of its primes. For example, we know 540 is 54 times 10. Just by looking at it, it ends in 0. That's usually an easy one to break down. And we can break down the number further. 54 is, for example, 6 times 9. 10 is 2 times 5. And this is as far as we can go because those are both prime. But 6 can be broken down to 3 times 2, while 9 gets broken down into 3 times 3. So if you ask yourself, how do I take the square root of that? Remember, I need to have the same factor twice in order to get that number to come out of the square root. So let's look here. We've got a 3 and a 3. So we know there's a 3 that comes out of the square root. Even though there's a third 3, I have to have it in a pair of 2 because it's a square root. We have a pair of 2's. So that means 1, 2 gets to come out of the square root because the square root of 2 times 2, which is 4, the square root of 4 is 2. Anything that doesn't have a pair gets left inside the square root. So we have a 3 times 5 inside the square root. Now 3 times 2 on the outside is 6. 3 times 5 on the inside is 6 square roots of 15. I think it's infinitely easier to break it fully down and see what you have. What the homework will tell you to do if you use the Help Me Solve This is they're going to tell you that the largest prime number that divides 540 is 36. 36 times 15. Why? Because they think that everyone knows the largest square that divides a number. You probably don't. But the point is, what is the square root of 36? It's 6, because it's 6 times 6. So you know that you have a perfect square of 36, so a 6 comes out, and that 15 can't be broken down into a perfect square from there, so you have 6 square roots of 15. I'm always going to operate under the assumption that this left one is easier to deal with. So 45 is 5 times 9. It's usually what people go for. 9 is 3 times 3. So again, we have a pair of 3's, so 3 gets out. We have a 5, which stays in. So this is just 3 square roots of 5. If you've got a number multiplied in front, it'll just get multiplied in, like the 3 times 2. 162. The easiest numbers to look for when you're trying to pair off factors are, is it ending in 0, is it ending in 5, or is it even? So 2, 5, and 10 are the easiest. This one's even. It's 2 times 81. Now you can break 81 down further, but you may already know that 81 is 9 times 9. And since 81 is 9 times 9, you know a 9 is going to get out of the square root. Even if you broke it down, we'd have multiple pairs of 3, and a 2 stays under the square root. So this whole thing, the square root of 1 becomes 9 times the square root of 2. But there's still this other 2 that's out front, so it's 2 times 9 square roots of 2, which is 18 square roots of 2. So if there's a constant already out there, you just multiply by it. If you have two numbers multiplied together, you can multiply them together and get the big number, like the square root of 100, but you can also break down each 10 and then look for common factors between both of them. So 10 is 2 times 5. Here 10 is 2 times 5, so we've got, between them both, since they're multiplied, we have a pair of 2's, 2 times 2, so 1, 2 gets out. We have a pair of 5's, 1, 5 gets out. There's nothing that goes under the square root, so we just have 10, which if we had multiplied it together, we would know that the square root of 100 is 10. Furthermore, the square root of a number times itself is just that number, because this is really the square root of 10 squared. So there's a lot of different ways to look at this. 115. If I break down 115, it is a multiple of 5. It's 5 times 23. But 23 is prime, and 5 is prime. So if I wanted to simplify this, I don't have any pairs. I have no pairs. All of them stay under the radical, and I just have the regular square root of 115. It can't be simplified from there, which is possible. You could get one that's not able to be simplified. Square root of 272. Again, if it's even, that's what I would go for first. 2 times 136. Still even, 2 times 68. Still even, 2 times 34. Still even, 2 times 17. Now, if you do it like this, it's only the bottoms of the branches that remain. The 2, 2, 2, 2, and 17. If they're not at the bottom of the branch, they've been broken apart into further pieces. Now here we've got a pair of 2's. We've got another pair of 2's, and we've got the 17 that's by itself on the inside. So this is 4 square roots of 17. If you have a different kind of root, that kind of root tells you how many of the same thing you have to have. So for a cube root, you'd have to have 3 of the same factor. Remember, for an odd root, you can bring the negative out. So negative 3 times the cube root of 54. If I break down 54, that's 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So because it's a cube root, I need to have 3 of the same thing. I have 3 3's, so that means a 3 gets out. The 2 doesn't have a pair or even a set of 3, so it stays under a cube root, same type of root you had before. Just combine the outside. This is negative 9 times the cube root of 2. Now, where does the simplifying help us? If we are adding and subtracting fractions. If you're adding and subtracting the same type of fraction, same type of radical, if you're adding and subtracting multiple of the same kind of radical, imagine the square root of 10, for example, is a cookie. If you have 5 cookies minus 7 cookies, you would have negative 2 cookies. So you really, if you have the same radical, you just add or subtract the numbers in front. The only way you can combine them is if they have the same number in front. So 5 square roots of 10 minus 7 square roots of 10 is negative 2 square roots of 10, just 5 minus 7 square roots of 10, which is negative 2. If they don't match, you need to try to get them to match. Here, for the square root of 32, 32 is 2 times 16. 16 is 4 times 4. We have a pair of 4's and a 2 that stays under the square root. So this is really 3 square roots of 2. This thing becomes 4 square roots of 2. Now that they have the same square root, I can combine them. 3 plus 4 is 7 square roots of 2. Let's keep going. Square root of 5 times square root of 15 plus 4 square roots of 3. 5 can't break down, but square root of 15 is 3 times 5. So I do have a pair of 5's. So this is 5 square roots of 3 plus 4 square roots of 3, which makes 9 square roots of 3. Just add the coefficients. If you have variables underneath, it can still work the same way. Let's break down the number. On the numbers in front, 12 is 4 times 3. K doesn't have a pair, so it's by itself, but 4 is 2 times 2. A 2 gets out. 2 times the square root of 3k, because the k doesn't have a pair, but if the k had a pair, it could get out. For 27, it's 9 times 3, which is 3 times 3, so we have a pair of 3's. And again, the 3 and the k have to stay. So this is 2 square roots of 3k plus 3 square roots of 3k. Again, you add the coefficients. This is 5 square roots of 3k. Again, we can do this with cube roots. If you have m cubed, the cube root of m cubed is m. So this allows us to get the m out because these two match. So this is 2m times the cube root of 16. Here, this is minus the m times the cube root of 54. For here, I'm breaking down 16. Remember, on a cube root, I need 3 of the same thing. 16 is 4 times 4. That's not 3 of the same thing, but if I break it down further, each 4 is a pair of 2's. So I get 3 2's that get out, 1 stays in. So we have 2m times 2 times the cube root of 2. Here, 54 is 2 times 27, which is 9 times 3, 3 times 3, so a 3 gets out. So minus 3m times the cube root of 2. And again, my root matches now. Now 2 times 2 is 4, so we have 4m cube roots of 2, minus 3m cube roots of 2. 4m minus 3m is 1m, so it's m times the cube root of 2. That's really all for 10.3 and 10.4.